Hi everyone. Let us have another discussion in science. But before that, I want you to listen attentively and you may watch it again if you have a little confusion about our topic for this day. Let's start. In this video, we are going to go over the atomic structure in the very simplest thing and basic way. So we're going to talk about the introduction and calculation of atoms. Atoms are said to be the basic unit of elements. They contain the subatomic particles in their nucleus and in the electron cloud that surrounds the nucleus. These subatomic particles include the protons and neutrons, which are located inside the nucleus. Also, it has electrons, which are located in the clouds or fields that surrounds the nucleus. Protons are said to be the positive charge, neutrons are neutral charge, and electrons are the negative charge. The number of protons and electrons are equal, so therefore, atoms are said to be electrically neutral particles. So remember, P stands for positive charge, N stands for the neutral charge, and E stands for the negative charge. P, proton, N, neutron, and E, electron. So if we look at the model of an element carbon, which has 6 protons, 6 neutrons, and 6 electrons in most cases, we can see the electrons in the simple rings or shell, which is actually surrounding the nucleus. Each shell represents different energy level, and it can only hold a certain maximum number of electrons. A chemical reaction between atoms, wherein only the electrons in the outermost shell can participate in the resulting chemical bond. In atoms with only one energy level or shell, 2 electrons are actually required for stability. If we look at helium, we can say that it has 2 protons, 2 neutrons, and 2 electrons. Helium has only one shell or energy level, and we can see it is full because the first shell can only have 2 electrons. So therefore, helium is stable and there's no naturally occurring compound that is actually containing helium. Unlike hydrogen, which also has one ring or shell, but it is chemically reactive. Hydrogen is actually chemically reactive. In atoms of more than one energy level or shell, 8 electrons are actually required in the outermost shell in order to attain the stability. So neon, which has 8 electrons in its outermost shell, is stable, while oxygen, which has only 6 electrons in its outermost shell, is chemically reactive. Atoms that do not have fewer than 8 electrons in their outermost shell will try to share, gain, or lose electrons to become stable. This is called octet rule, but there are some exceptions such as we saw it a while ago for the element of hydrogen and helium, which only have one energy level or shell. So we are done on the introduction of the atomic structure. Let us now have and move on to the calculation of the subatomic particles. Commonly, we use periodic table of elements to answer our queries about the name of elements, what is its symbol, number of protons, electrons, and neutrons. and we are here to deal with its calculation. So to better understand its calculation, I used here the table which corresponds to the name of the element, the symbol, atomic number, protons, neutrons, electrons, and mass number. Let us find out the missing information using this table. We have here the following elements, such as silver, potassium, tin, fluorine, and magnesium. But before that, let us have the element carbon as our example. First, you will see that the symbol is at the center of this element. It can be one or two abbreviation that is derived from the element's English or Latin name. For carbon, it has a symbol of capital C. Just above, on its upper right corner, is the atomic number of the element carbon, which is actually equal to the number of protons and to the number of electrons. This is actually only for neutral element. Below the name of the element carbon is the atomic mass. Atomic mass is weighted as an average masses of all the elements isotopes if you round up to the nearest atomic number of the given atomic mass. So therefore, instead of having atomic mass, once you round up the given atomic mass, it is already called as mass number, wherein it is equivalent also to the number of protons plus the number of neutrons. But for neutrons, in order for you to get the value of it, you need to subtract the mass number to the number of protons. So, don't be confused between the term atomic mass and mass number. Atomic mass is the mass of an element in the periodic table. Once you round off the atomic mass to the nearest atomic number, you can have already the mass number. And mass number can be solved using the summation of the number of protons and the number of neutrons. So there you have it. We can now start solving for the atomic number, mass number, proton, electron, and neutron of an element. Remember that atomic number is the number of protons, atomic mass is the average number of protons and neutrons of all isotopes in an atom, while mass number is the number of protons and neutrons of a specific isotope in an atom. So that's the difference between the two, atomic mass and mass number. So let's start. Let us now solve for the missing information using the table. Let us start with silver. Using your periodic table, it is very obvious that silver has a symbol of Ag. It came from the Latin name argentum. So you will write there Ag. For the number of protons, since in our formula, atomic number is the same with the number of protons and the same with the number of electrons. Since our atomic number here is 47, therefore, our proton is also 47 and our electron is also 47. Now for our mass number, given the atomic mass which is 107.8682, we can now calculate the mass number. Mass number is the rounded off of the atomic mass. 107.8682 is when you round off, is equivalent to 108. So therefore, since you have the mass number, you can already solve for the number of neutrons, which is equal to the mass number minus the number of protons. 108 minus proton, which is 47, our neutron is 61. So therefore, here's the correct answer for the element silver. Did you get it? Easy, right? So let's move on to the second element. Let us have the element potassium with the symbol of K. K, it came from the Latin name, which is kalium. In order for us to get our atomic number, the atomic number of potassium here is 19. Therefore, the number of proton is also 19 and the number of electron is also 19. Since we are looking for the mass number, from the given atomic mass, you have 39.098. Our atomic mass, when you round off, is also equivalent to 39. So in order for you to check if your mass number is correct, you can subtract, to get the neutrons, right? You can subtract the mass number to the number of proton. So to check your answer, you will have 39 minus 19. Therefore, from the given, neutron is equivalent to 20. So therefore, you get the correct answer for the missing information of the element potassium. Now, let us have the third example, which is tin, with the symbol of Sn, came from the Latin name stannum. For the atomic number of tin, it is 50. Therefore, the number of protons are also 50 and electrons are also 50. For the mass number, if the atomic mass is 118.71, round off to the nearest mass number, you can have 119. And for the neutron, mass number, which is 119, minus the number of proton, which is 50, the correct answer is 69. So, therefore, we have the missing information for the element tin. So, in order for you to test if you understand our lesson for this day, and since you already know the concept, let us have a short activity. Now, you will solve for the missing information of fluorine and magnesium. You only have 1 minute to solve for the missing information, and you may start now. I'm going to show already the answer for silver, potassium, and tin since we solved it a while ago. So you may start. So you have already the guide there for our answer for the elements of silver, potassium, and tin. Last 10 seconds and we will check your answers. So time's up. Let us check your answer for the element fluorine. Fluorine with the symbol of F. For the atomic number, it has atomic number of 9. Therefore, the proton is also 9 and the electron is also 9. We already have the given mass number, which is equivalent to 19, and we are now looking for the value of neutrons. So in solving for the value of neutrons, you can have mass number minus number of protons. So 19 minus 9 is equivalent to 10. So if you got it correctly, you have 1, 2, 3, 4, 5. 5 points. 1 check for each missing information. And last but not the least, let us have magnesium. Magnesium has a symbol of Mg. For the atomic number, it has 12. Therefore, proton is also 12 and electrons is already given 12. Now we're looking for the mass number and number of neutrons. Let us now have first the mass number. Mass number from the given atomic mass 24.305. When you round off, it is equivalent still to 24. And to solve for the neutrons, 24 minus 12 is equal to 12. So there you have it. We have the correct answer for magnesium. So still you have 5 points. So 10 points for the activity about fluorine and magnesium. So we are done. So that's it. We are done. But remember these 3 statements. Atomic number is the number of protons. Atomic mass is the average number of protons and neutrons of all the isotopes in an atom. And mass number is the number of protons and neutrons of a specific isotope in an atom. And so we are done. Thank you everyone for listening. See you again on my next video. To keep you updated, you may subscribe to my YouTube channel, Ma'am PM is the key, and hit the bell button and select all in order for you to be updated to my new videos. Hope you enjoy my discussion. Goodbye!